Hi, welcome back. In this video, we're going to do a little review of inverse trig functions. So there are actually 6 of them, but in this video we're just going to talk about 3 of them, the 3 that we'll use most often. So the first one we're going to talk about is the inverse cosine function. So the definition is the inverse cosine of x equals y means that the cosine of y equals x and y is between 0 and pi inclusive. So it could be equal to 0, could be equal to pi. So why do we have to have that restriction on y? Why can't we just say inverse cosine of x equals y means that cosine of y equals x? Well, remember, it has to be a function, so there has to be exactly one output for each input. And recall that the cosine function is periodic, and so there are infinitely many inputs that have the same output. So this is the graph of the cosine function. It does not pass the horizontal line test. If you draw a horizontal line, it will intersect the graph infinitely many times. So technically it doesn't even have an inverse. But mathematicians decided a long time ago we need an inverse for this function. It's really important. Given a cosine value, we need to have an angle to go with it. But there are too many choices, right? So given some number between -1 and +1, there are too many angles to choose from. So we got to restrict the domain so we know exactly which angle to choose. So why did they decide 0 to pi? Well, they wanted a compact enough interval that was close enough to the origin, but also it included all the numbers, the outputs included all the numbers between -1 and 1, but only once. So notice if I restrict my domain to 0 to pi, you can see that I'll get my outputs will include all the numbers between -1 and 1, and will include them only once. They won't get repeated. So they decided on that interval. Similarly, with the sine and the tangent, they did something similar. So the definition of the inverse sine function is inverse sine of x equals y means sine of y equals x, and y is in this interval between -pi/2 and +pi/2, and includes the endpoints. And that's because on that interval, for that function, you'll get all the numbers between -1 and 1, but you'll get them only once. And then for the tangent, the inverse tan of x equals y means tan of y equals x, and y is between -pi/2 and +pi/2, not including the endpoints. And remember, the tangent function has vertical asymptotes at -pi/2 and +pi/2, so can't include those numbers. So remember those restrictions when you're working with these inverse trig functions. Let's do a quick example. Let's find the inverse tangent of -1. So remember, the inverse tangent of -1 is the angle whose tangent is equal to -1, and it's in a certain interval. So what angles have tangent equal to -1? Well, tangent is sine over cosine, so if it's negative, then the sine and the cosine have opposite signs. One is positive and one is negative. But also it's -1, so that means that the sine and the cosine have the same absolute value. So remember which angles have that property. So the angle 3π/4 has tangent equal to -1, because the sine is positive √2/2 and the cosine is negative √2/2. Also, 7π/4 has tangent equal to -1. The sine is negative root 2 over 2, and the cosine is positive root 2 over 2. Well, it turns out neither of those works. Neither of those is the correct answer. The correct answer has to be between negative pi over 2 and positive pi over 2. So it's the angle negative pi over 4. That's the only one that works. So there's always one answer, and you have to remember the restriction on the angle. Okay. All right, let's do a different type of example. Let's simplify the tangent of the arcsine of x. So we don't have any numbers, we just have an x. So what we're going to do is we're going to use the definition of the inverse sine function to rewrite the arcsine of x. So let's give it a name. Let's call it theta, because we know it's an angle, and we like to use Greek letters for angles. So theta is arcsine of x. That means that the sine of theta has to be x. Now we can draw a right triangle, because we know that theta has to be between negative pi over 2 and positive pi over 2. So we can say that theta is one of our acute angles. Also, we always let our hypotenuse be 1. We could let the hypotenuse be anything, but 1 is a nice simple number. It will make our lives easier. So I labeled my hypotenuse 1, and I'm labeling one of the acute angles theta. So now, since I know sine of theta is opposite over hypotenuse, I can label the opposite side x. So x over 1 is the sine of theta. And now I can use the Pythagorean theorem to label the third side of my triangle. So using the Pythagorean theorem, I get the square root of 1 minus x squared. Now, what we're looking for is the tangent of theta, because the tangent of arc sine of x is really just the tangent of theta. So looking at that triangle, the tangent of theta is going to be the opposite over adjacent. So it's x over the square root of 1 minus x squared. So that means that's what we were looking for. The tangent of arc sine of x is x over the square root of 1 minus x squared. Done. All right, so make sure when you're using the inverse trig functions, you remember the restrictions on their domains and their definitions. And I will see you in the next